All right, so in this video, we're going to continue to talk about inequalities. But we're going to learn about what a solution is to an inequality, and then we're going to learn about graphing inequalities. So, if you were to have an inequality that looked something like x minus y is greater than 4, how would you know what a solution to that inequality is? For example, you could check to see if some ordered pair is a solution by just plugging in these values. So if you remember, an ordered pair is given x, y. So you can plug in x equals 0 and y equals 0 into this right here. So we're going to get 0 minus 0 is greater than 4. 0 is greater than 4, which is a false statement. So we know that 0, 0 is not a solution, right? But if you were given the inequality 3x minus 4y is greater than negative 1, and you wanted to check if 3, 0 was a solution, you can plug in x equals 3 and y equals 0. So we're going to get 3 times 3 minus 4 times 0 is greater than negative 1. So 9 minus 0 is greater than negative 1. So 9 greater than negative 1. That is a true statement. Therefore, 3, 0 is a solution. Now, that would be really tedious to go through every single point on a coordinate plane to determine if it's a solution or not. So a better way to determine solutions to an inequality is to graph your inequalities. All right? So if you've got this inequality, y is greater than x minus 2, and you want to figure out the solutions to this inequality, we're going to go ahead and graph this inequality and learn how to graph this inequality. So the first thing you want to do is you just want to treat this like any regular line. So you're going to go ahead and graph this line right here. Now there's a couple things you want to remember when you're graphing a line. You're going to want to remember what your slope is and what your y-intercept is. Now, if you remember, your slope is this value given before your x. So in this case, it's 1. And then this right here is your y-intercept, which is negative 2. Now, you also want to determine if you're going to graph with a solid or dotted line. Now, you're going to graph with a solid line if your inequality is less than or equal to or greater than or equal to, and a dashed if it's simply less than or greater than, and there's no equal to. So it's kind of like when we had our open circle or closed circle. You remember that our closed circle was the ones that included those values, that they were also equal to those values. Same as with our dashed and our solid lines right here. If you're going to include those values, so it's also equal to those values, then use a solid line. If not, you're going to use a dashed line. So in this case, we've got a greater than sign with no equal associated with it. Therefore, we're going to use a dashed line when we graph this line. All right, so we can come over here, draw our coordinate plane. Now, we know that our y-intercept is negative 2, so we're going to come down 1, 2. It's our y-intercept, and then our slope is 1, so we're going to go up 1, over 1, up 1, over 1. So that's our line, but you remember we've got to make it dashed. So come in and make that line dashed like that. All right. Now we're going to have to shade one of the sides of this line. So either the top or the bottom of this line is going to be shaded because it's an inequality, right? So in order to figure out which side you're going to shade, we're going to use a test point. I like to choose something easy, so like 0, 0, or like 1, 1, or something like that that's just really simple to plug in. So again, I'm going to use 0, 0 in this example, and you just go ahead and plug this solution back into your inequality. So we know that x equals 0, y equals 0. We're going to plug that in, so 0 is greater than 0 minus 2, 0 is greater than negative 2. That's true. So 0, 0 is a solution, so that side of the line is going to be shaded. So 0, 0 is right here, so this side of that dashed line is all shaded. Now, if you chose a different test point, say for example, if you selected 4, 0 as your test point, you'd come in and you plug this back into your inequality, so y greater than x minus 2. So y is 0 greater than x, which is 4 minus 2. 0 is greater than 2. That's false. So our point 4, let's see, 1, 2, 3, 4, 0. That's false. So this side of the line here is unshaded, so you'd come in and you'd shade this side of the line. So as you can see, you get the same answer either way, regardless of whatever test point that you choose. All right. Now, another thing to point out, again, just to emphasize, if this was a greater than or equal to sign, like that, you would come in and make this a solid line right here. Right? So if you've got this down here, it's solid. If you get rid of this, then you get a dashed line like that. All right, and so the interpretation of this graph right here, what that means is any of these values on this side of this line right here, these are all solutions to that inequality. Everything over here, not including this line because it's dashed. If this line was solid right in here, let's get a different color so you can see it. If this line was solid, then you would include these values. But if it's dashed, you don't include them. All right? So that's how you find solutions to an inequality.